learners. My name is Ogega Gabriel. Welcome to today's lesson. We are going to talk about Form 3 matrices, and I know it's a new topic to our Form 3 students. I'm going to begin by defining what a matrix is. Definition of a matrix. A matrix is a rectangular arrangement of numbers. So any rectangular arrangement of numbers, such a thing is said to be called a matrix. And a matrix can contain rows and columns. A matrix can contain rows and columns. So in that case, we are going to look for the examples of we are going to look at the examples of matrices that we have, and we have two major examples of matrices. So examples of matrices that we are going to deal with in our entire lesson and even topic. One, we have the square matrix. And two, we have the rectangular matrix. So a square matrix and a rectangular matrix are the kinds of matrix that we are going to look at. So let me begin with the square matrix. And I will begin by defining it. A matrix is said to be square. A matrix is said to be a square matrix. If and only if the number of rows equals to the number of columns. So i.e. we have A, B, C, D. So this one is a square matrix, which is a 2 by 2 matrix. The number of rows, as you can see, 1, 2, is equals to the number of columns, 1, 2. So such a matrix is said to be a square matrix. More examples of square matrices. We have 1, 2, 3, 4, 5, 6, 9, 7, 2. So this one is a 3 by 3 square matrix. This is because the number of rows are 1, 2, 3. And the number of columns are 1, 2, 3. So since the number of rows equals to the number of columns, we give this matrix a name as square matrix. Secondly, I'm going to talk about the rectangular matrix. And a matrix is said to be rectangular. if and only if the number of rows is not equal to the number of columns. The number of rows is not equal to the number of columns. That's when we say a matrix is said to be rectangular, i.e. A, B, C, D, E, F. This one is a rectangular matrix. And more examples of rectangular matrices. We have 1, 2, 3, 4, 5, 6. This one is a rectangular matrix. 1, 4, 5, 6, 7, 8. This one is another rectangular matrix, and so forth, and so forth. So this is how we are going to identify the kinds of matrix that we are going to work with. Generally, we can denote square matrices as follows: an n by n matrix. So this one is a square matrix, any n by n. N by n implies that n is equals to n, so that one is a square matrix. And for the rectangular matrix, we are going to denote it as m by n matrix, which implies that the number of rows, which is m, is not equal to the number of columns, which is n. So in that case, it will be easier for you to identify the kinds of matrix that we are going to work with. Thank you for watching, and please subscribe to this channel.